All right, our third type of transformation we're going to talk about is a rotation. So a rotation of x degrees about a point r. So of course we got to have a point about which we're rotating, and that point is a fixed point called the center of rotation. It's a transformation with these two properties. Number one, the image of r is itself, so r equals r prime. That's the point of rotation, right? So it's going to stay the same. And for any other point v, rv prime equals rv, and the measure of the angle of rotation is x. Okay, so there's a picture of that. I know that's kind of hard to understand, but there's a picture of it right here. So you see r is r prime, and the pre-image v and its image v prime. So here's v prime, are equidistant from the center of rotation. So we're going to maintain distance when we do a rotation. So each vertex of whatever figure we have is going to stay the same distance from the center of rotation. And I think I failed to mention this with respect to reflections in the last lesson, but a reflection also maintains distance. Every image will be the same distance from the line of rotation that the pre-image is. Same holds true for rotations. The positive number of degrees a figure rotates is the angle of rotation. And so really, all that's left here is for me to tell you what these rules of rotation are. And of course, you have to remember them. You have to memorize them. So if I'm going to rotate 90 degrees counterclockwise, all these that I'm writing down here are counterclockwise, and my center of rotation is the origin in all these cases, then 90 degrees counterclockwise, here's the rule, xy is going to go to negative y, x. All right, if I'm rotating 180 degrees counterclockwise, xy would go to negative x, negative y, and 270 degrees counterclockwise, xy would go to y, negative x. So you just have to apply these rules to your vertices, or maybe we're just rotating one point. It doesn't matter. So why am I only giving you rules for counterclockwise rotation? Well, think about this. How about 180 degrees? Does it really matter which way I go if I'm rotating 180 degrees? It's going to be the same. So clockwise, the rules would be the same. 180 degrees clockwise is the same as 180 degrees counterclockwise. What about 90 degrees counterclockwise? What would be the same, what would be equivalent to that rotation if I were going clockwise? That'd be 270, right? 270 degrees clockwise would be the same as 90 degrees counterclockwise. And for 270 degrees counterclockwise, I could just go 90 degrees clockwise and I'd be landing at the same place, right? So that's it. You have to memorize these. Okay, let's see what it looks like. Triangle ABC. Okay, let me pause here and graph my triangle ABC, and then we'll come back and we'll rotate. Okay, so there's triangle ABC, got the vertices in here. I'm going 90 degrees counterclockwise. So from my table on the previous page, I know for a 90 degree counterclockwise rotation, here's my rule, negative y, x. So before I graph it, I'm just going to write that down. So A is 2,7, so that means I'm going to change it to negative 7, 2, right? The x component, the original x component in the pre-image changes to y, and I make it negative, and the original y component in the pre-image becomes the x component, and that's all I got to do. So B prime is going to be negative 5, 6. C prime is going to be negative 1, 4. I'm going to come plot those over here. 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6, 7, positive 2. So there's A prime. B prime, negative 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And C prime, negative 1, 4. 1, 2, 3, 4. There's C prime. Let me draw that in. And it's really hard to tell just by looking whether I've actually done the correct rotation, but what you can do, remember this, guys, here's my center of rotation, right? My center of rotation, we'll call that R. Okay, so if I draw a segment from my center of rotation to the pre-image and to the image, it's going to make a 90-degree angle, right? So let me draw a dashed line in here to C and one to C prime, and that's going to be a 90-degree angle. Same thing for B and B prime. Let me try to get a different color here. If I go from R to B, and then R to B prime, I got another right angle. Same thing's going to happen for A to A prime, right? I guess I could use black for that. So R to A is right there. R to A prime is right there. And again, all those angles are 90 degrees because that is my center of rotation. So the center of rotation will be the vertex of the angle created when you draw the segment from that center of rotation to the pre-image point and then to the image point. All right, so really all you got left here are a couple more problems to practice. I'm going to let you do those. I'm not even going to fill them in because you just have to apply the rule. Now here I've written one as a super duper challenge problem. And I'll give you a hint of how I do a problem like this, because what makes this difficult is because I'm not rotating about the origin. I'm rotating about this point right here, 3, 2. So let me draw that on my graph. Point 3, 2, 1, 2, 3. So there's my center of rotation. I'm going to call that R. So what I would do, helpful hint, is I would let that be my new origin. Let that act as the origin. So it's going to stand in for your origin, and then you're just going to apply the rotation rule using that as your origin, and then you'll have to change the coordinates back. And if you get all stumped on this, then we'll definitely talk about it next time. So we're going to say let that act as the origin and then apply the rules. And I'll tell you what the answer is when you get finished. You're going to have that A double prime is 3, negative 1, and B double prime is 2, 6. All right, so you go ahead and work these other example problems. You definitely need to do all these. There aren't that many, and that's all for today.